Everybody, we're live here from the OSS Summit. Well, not live, but we're live, but you're watching this recorded. See? OSS Summit. Yeah. All right. So I'm here with Kim Wilkins. She is our tech lead for MongoDB, and she's been with us for a couple years now, is it?
Well, a year and a half, year and a quarter.
But you round up.
Yes.
You round up.
And conferences for years and years before that, yes.
So we're here to talk about MongoDB, specifically MongoDB application design and performance.
Right. And architecture, right?
And architecture.
All those different things.
Design,
all the components.
architecture, all the little things.
All the things that can make your life joyful or extremely painful.
But you don't need that, right?
No.
It just automatically happens for you.
Schemaless.
It's schemaless.
Schemaless.
It's performant out of the box?
Well, that's one of the things that One of the reasons that developers so much love MongoDB from the beginning is because it is schemaless. However, what you put in, you put out. There's that old saying, garbage in, garbage out. So just because it is schemaless does not mean that you should not consider design and architecture, especially based on what your application patterns are.
Well, but okay, so, MongoDB stores BSON.
Right.
Which is almost identical to JSON. Right.
Right. Binary,
format.
smaller, yes.
Yeah. So the whole point, though, is the ability to add and change and evolve, right?
Right, and that's its beauty, right? MongoDB will store structured, semi-structured, and unstructured data. So you can put in exactly what you want. You can change your schema on the fly. Your documents from the beginning of your design, when you first started your company, can look vastly different from what you evolved to 2 or 3 years later, as you've added on components and layers to your application and functionality.
So how does that slow down, though? If you're making those changes frequently, what happens?
Well, it depends, right? Some of the things that you do from the performance aspect of it, indexing. If you have too many indexes, as we all know, it's almost like the same as any other database technology. Too many indexes, you have to maintain those indexes. Every time you do any kind of write activity, you maintain them. So that then therefore slows things down. Right?
So you're talking about slowdowns and inserts or updates or changing the documents.
Right. But in terms of the architecture of the overall, when we talk about the architecture of the overall instance of the cluster, it's a little bit different, of course, than your application design patterns.
Okay.
So MongoDB handles and works with all the different, many. Some people say there are 12. We don't need to go into all those different ones, but use cases and or design patterns it handles. The traditional idea is that it handles very well product catalogs and those type of things, and a lot of the different social media apps or chat boards and these type of things. However, as we both know, as MongoDB has grown, it's added these features and functionalities, including the ability to do transactions and then multi-document transactions. Now we're getting to version 5.0, released most recently, and it's adding time series collections. But we'll have a whole nother series going on where we'll do a deep dive into just time series collections. My point is that MongoDB has added these functionalities to become capable of doing more and more for everyone at the same time without having to utilize, a graph database for this, et cetera.
Yeah. Okay. And so what other things do people run into in terms of performance issues?
So a whole other topic, of course, again, performance would be sharding. But if you design your architecture, your platform, your instance, your cluster incorrectly. For example, if you have a replica set and it grows to be, 5 terabytes, and it's all running in a single replica set, what have you done? You've reintroduced the old big machine style bottlenecks into your system, right? So you should still be looking at MongoDB for its horizontal. But if you do those I/O places, the disk I/O bottlenecks or the memory bottlenecks, where your scatter gathers, you have to go out to too much, you have to do too much sorting, the same problems that you've run into in the past with relational databases. So by keeping them smaller overall and by doing the horizontal scaling, which is, sharding, separate topic, then realistically you help be more performant in general.
Okay. And are there common mistakes you see?
Common mistakes that you see is, for example, having the wrong type, if you're in the cloud, associating the wrong type of storage disk, right? Because with Mongo, you're going to have most likely a lot of connections, right? A lot of connections means you're going to need dedicated IOPS and throughput to the machines. You're going to have the network to handle it. Another thing a major mistake is your connection pool settings. If you have your connection or your retry logic, for example, if your driver retry logic is not in place to retry, then a transaction gets interfered with, it doesn't complete. And by transaction, I don't even mean ACID compliant transaction, I just mean an action into the database. It doesn't complete, where does it go? It can become lost, right? So that's one of the things. But the primary things, every connection that you make to the MongoOS requires memory. And if you have a lot of connections, you're not closing your connection pools or reusing those connection pools, then you're spinning up a lot of additional memory for no reason, and you start just consuming that and start thrashing, right? Another thing, even at the lower level, when you're setting up your machine, right, if you don't set up, obviously, you don't set up swap correctly.
Right.
Right? Or with WireTiger Engine, if you don't set up your correct ratio for the cache, and then you start to run out of tickets. So some people may not realize that you can tune the cache for the I/O. But the bigger thing is, of course, to watch your resource contention, and if you see spikes happening in that, you either look at your disk, your I/O stat, you look at your memory. It goes back to some of those same old tried and trues. You look at your WireTiger tickets for reads and writes and see if they're being saturated and overused.
Okay.
And things like PMM, right, will tell you a lot of those things.
So you're really looking for how are you using connections? If you're, saturating via connections, having too many, that could cause issues. You look at the tried and true disk I/O, CPU, memory statistics. You look at the cache to see what's being evicted from cache, to see if you've set that properly.
Right.
So it's a very standard process to go through that.
Yes, and a lot of the things is, MongoDB in its heart has those. It's much more at the OS level that you're looking for some of those problems. There's a lot of tooling out there now, right? Like I mentioned a minute ago, PMM, there are a lot of other tools out there. But in the heart, you do need the basic understanding of the system. Okay. Because when it comes down to it, your performance relies on your initial setup and architecture for the system. But then we get to the queries, right?
Yes.
Because in the end, it's always about queries. Remember back in the day when and I probably still today, when the ODM systems would send the most horrendous queries to your SQL databases, right? Well, anything that sends a horrendous query to even an unstructured, schemaless, NoSQL database will encounter problems. And so, again, the primary thing you originally first will look at will be indexing. But it's not always going to be indexing. It can be just the nature of the queries that itself you're looking for. And then sharding, right? But sharding, whole separate topic. But a bad shard key, in whichever terms that you have a shard key be bad, whether it's in terms of the frequency, the cardinality, if it's serially, sequentially, like a sequence monotonically increasing, those typical sharding problems. So now we're in MongoDB 5.0 and MongoDB 4.2, they made it so that you could change the value within a shard key. In 4.4, they made it so that you could add a field to
the shard key. So
right?
instead of having one field you're sharding on, now you can add a second or a third.
Right. Well, the second, you could try to, as a suffix, right? So basically, we'd be adding an additional field to provide additional cardinality, and that would help you prevent jumbo chunks, which, of course, jumbo chunks cause massive slowdowns because they can't in a sharded environment. Again, we're kind of getting into the next topic, but it's so easy to do because that's where so many of the problems lie. So,
okay. Yeah. All right.
And then manageability. Part of performance and part of the architecture also deals with the manageability of your system. If you have, going back to the jumbo replica set, single replica set, if you have that architected, if you had a 1, a 2, a 3 terabyte replica set shard, you may think, okay, great. No, this can handle it, and I'm not querying it too much. This is primarily just writes. I've got it designed with enough memory, enough RAM, so that I'm not hitting throughput problems, input problems. But what happens when you have to fall off the replication? What happens if you get replication lag? What happens if your secondary gets too far behind and you have to perform a reinitial sync? And it takes, 24, 32 hours to resync that. What happens when you have to back that up? And which backup utility are you trying to use? Is it physical or is it logical? So all these considerations, people think Mongo is super easy to use. Developers love it, and that's why it has the popularity. But you do have to actually still put some thought into designing the system overall. So.
Okay.
Yeah.
Well, thanks for giving us those tips and tricks. So it isn't just as easy as turning it on. there are some things you need to do to make sure it works correctly.
Yes, that's exactly right. And thanks, Matt. And I guess bye-bye from Seattle.
All right. Thank you.
Thanks.